On today's episode, we are getting into the latest space news, including the Dream Chaser spaceplane is ready to fly, while Boeing's Starliner fails some crucial safety checks and is grounded indefinitely. This is the space race. On May 31st, representatives for Sierra Space, the aeronautics company behind the Dream Chaser shuttle project, confirmed that their vehicle had been successfully powered up for the first time. The mostly complete airframe of what will be the first Dream Chaser, called Tenacity, was fed power during a test of the vehicle's electrical systems. This is an important milestone for Sierra Space, as it means that their shuttle is ready to leave their assembly facility in Louisville, Colorado. The next and final round of tests before a potential first flight are to be completed at NASA's Neil Armstrong Test Facility in Ohio. This is where the most important checks, those being thermal and vacuum testing for human habitation, will be completed before the hopefully successful Dream Chaser will be shipped to Cape Canaveral for launch preparations. The first Dream Chaser flight will involve the DC-100 cargo variant, as this uncrewed version was easier to get built for test flights, but a crewed version, the DC-200, is definitely in the works, and astronauts are being trained in its use as we speak. However, the first launch hasn't been announced yet, partially due to Dream Chaser being still in the testing phase, but also due to the United Launch Alliance's Vulcan Centaur rocket facing its own delays. Dream Chaser is currently designed to be launched on that particular rocket, and we say currently designed because this spaceplane has to be one of the longest running design projects in spaceflight history. Dream Chaser as a concept has been building towards this goal for over almost 2 decades now. The project was started back in 2004, 7 years before NASA's original shuttle program was officially mothballed. Back then, there was nothing really ready to replace the shuttles, certainly nothing with the same sort of reusability, but by 2004, NASA knew it needed something to replace the aging shuttles, and so a couple of projects started up to find solutions. One of them eventually became what we know as the Artemis program, but a series of smaller companies that mostly don't exist anymore decided to build a better shuttle based on older NASA designs for commercial flights. Those companies didn't just kick the can down the road for 2 decades either. Each of the buyouts came with renewed support for the engineering team behind the project, more testing and more innovations as tech improved, leading to what we have today, a supersonic spaceplane with very few moving parts that can be easily launched and retrieved. The current design team, Sierra Space, is designing Dream Chaser to work primarily with commercial applications, specifically Blue Origin's upcoming space station, the Orbital Reef, and surprisingly, not much of the original plan has needed to change. The basic concept that still survives in today's model is one of a compact vehicle with a lifting body, meaning that the entire body of Dream Chaser acts as one big wing, allowing it to glide unpowered fairly well. NASA shuttles had more or less the same design, albeit on a larger scale, and it meant that they could be guided down to runways fairly easily by the onboard computer or a skilled pilot in an emergency. Dream Chaser keeps that idea and uses a very similar thermal protection system with some modern twists. Silica-based black tiles form a heat shield on the belly, very much like the NASA shuttles, while a new composite called Toughened Unipiece Fibrous Reusable Oxidation-Resistant Ceramic covers the nose and the leading edges of the wings. Tough Rock is basically ceramic fiberglass, and it's some amazingly heat-resistant material, able to withstand up to 3,600 degrees Fahrenheit. The biggest new innovation, however, is the Large Integrated Flexible Environment, or LIFE module. This is an inflatable habitat, a lot like the Bigelow inflatable HABs that were tested on the ISS in 2022. It will be installed in the crewed versions of the Dream Chaser and take the shuttle from being about 4 times shorter than the old NASA shuttles to unfolding a HAB about 27 feet in diameter, which is roughly a 3-story building. And it's easy to launch too, which is probably the most important advancement from the older shuttles. Currently, Dream Chaser is meant to be launched on the top of the ULA's Vulcan rocket, along with its large Shooting Star cargo module. That module is a bulky addition that attaches to the rear of Dream Chaser and can hold up to 9,900 pounds of pressurized and unpressurized cargo. The Shooting Star is another example of Dream Chaser's versatility. It can be used to ferry around modules and scientific gear designed by other groups. Dream Chaser as a project is unique, but only for this era of the space race. Its development is not overly different from NASA's Space Launch System, both of which were developed under various project names and with teams of engineers from many different companies, universities, and international partners. In that respect, it's wild that Dream Chaser is still going, but looking back at its development, you can see a history of very dedicated engineers taking their time and adapting the design of NASA's shuttle into something more feasible and much more manageable. Dream Chaser is a really cool concept, but that doesn't explain how it has survived 2 decades of testing across so many programs and teams. What does explain it is that while the technology and need for something like the current Dream Chaser didn't really exist back in 2004, they definitely do now. And with Virgin Galactic going belly up and being sold for parts, Sierra Space doesn't really have a lot of competition in the commercial spaceplane field anymore. Dream Chaser represents a cheap, versatile platform that can be used to haul cargo to space stations like the ISS and the Orbital Reef just as easily as it can be used to push a scientific satellite into the correct orbit before heading home to land easily on a runway. You can't do that with a capsule. On June 1st, NASA called a press conference to discuss the upcoming crewed flight test of the Boeing Starliner capsule. The flight was due to lift off sometime in July and unfortunately ended up being the focus of the announcement. That's right, Starliner has been delayed again. In the run-up to the test flight, Boeing's capsule was undergoing the same rigid inspection processes that any other vehicle goes through, and several long unnoticed safety issues were discovered during those inspections. First off, the soft links on Starliner's parachutes were not strong enough. These are the lines which connect the parachutes to the capsule itself. NASA requires them to be strong enough so that if one line fails for whatever reason, the other two can take the strain and land the vehicle safely. Starliner's lines were not able to do that. That is a big safety issue, and it's weird it wasn't caught way earlier, but it's actually relatively easy to fix. Boeing's engineers say they'll need to remove the chutes and repack some new ones, which will require the removal of the forward heat shield at least. What isn't so easy to fix is their other problem. It turns out that a particular type of tape that engineers used on the wiring harnesses inside the Starliner has a flammable adhesive, so the entire electrical system of the space capsule is a potential fire hazard. There's not much information on how that one got past inspections for the previous 2 flight tests, or how that tape was chosen at all, but it's a pretty big oversight. Fire in space is what the people at NASA describe as not good, and Boeing should know that. Boeing does have a plan to fix the issue, which will likely involve applying layers of fire-retardant material around the areas of the pod that could be exposed to fire. Wiring harnesses are taped extensively for organization, so it would be impossible to remove all of the offending material without just starting from scratch. So better to just address the problem areas on this pod and remember this lesson for the next one. But even with that more targeted approach, Boeing engineers will have to crack open several panels inside the spacecraft and reseal them afterwards, which will take a lot of time. This is why NASA has not given a new date for Starliner's crewed test flight, and it's really difficult to feel bad for Boeing right now. Starliner was commissioned back in 2014. NASA awarded a commercial crew contract to Boeing for $4.2 billion, and at the same time gave Elon Musk's SpaceX $2.6 billion to develop Crew Dragon for the same job. NASA likes redundancy, and boy did it pay off this time. Back in 2014, it's likely that industry insiders would have placed their bets for the veteran Boeing to be able to design a working crew capsule before SpaceX, but by 2020, Crew Dragon was carrying its first batch of astronauts into space, and Starliner's first uncrewed test had failed to dock with the ISS barely a couple of months before that in 2019. Boeing wouldn't have a successful uncrewed test until 2022, and even then, there were problems. Software issues, sticky valves, and thruster failures all painted a bleak picture for Boeing. All while, SpaceX was setting records with their Dragon vehicle. Boeing even had issues with the capsule's cooling system and docking ring. Their successful test seemed to really stretch the meaning of that word. Regardless, it was successful, and once back on Earth, Boeing got to work fixing all the issues discovered during that mission. It just seems so comical to have them complete all this design work, try 2 test flights, and then just before their first crewed launch, find issues they should have spotted at literally any point in that process. It's like stepping on rakes. Of course, NASA has said that they are behind Boeing 100% and intend on supporting them while they get the finishing touches on Starliner finished. But at this point, why are they sticking with Boeing? It's definitely not because NASA needs the redundancy anymore. Aside from SpaceX's Dragon, which has proven very reliable on its own, NASA is still making use of Soyuz capsules, not to mention cargo vehicles like Cygnus and JAXA's HTV vehicles. At this rate, even Dream Chaser will be able to service the ISS before Starliner. The most likely reason is that NASA has sunk a fair amount of money into the Starliner project, and once Starliner gets these last few kinks out, it's hard to imagine that there could be anything else wrong waiting to be discovered. I can certainly understand wanting to not abandon a basically finished product. The only other reason would be that Boeing is a longtime partner of NASA. They have worked on a lot of projects together, which makes sense as Boeing is an aerospace giant that has been operating since 1916. They helped make a lot of the parts for the SLS, which suddenly makes all the issues with that vehicle make sense. But honestly, at what point does NASA put a stop to this project? They have spent a ton of money on Starliner, only for Boeing to embarrass them with issues that seem pretty avoidable. If the Starliner team fix up their capsule and fail to launch it again, we're not so sure that there's going to be any future NASA contracts waiting for Boeing. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do 1 long form essay and 1 news update every week. And if you'd like more, we've got 2 more on the screen for you right now.